again a very good afternoon to all of you, ladies and gentlemen. We are going to commence with our post-lunch session, and before commencing the formal technical session 2, we would request Mr. Renewable, Deputy Manager from SKF India, to make a short presentation, and after that we are going to commence our technical session 2. There will be a 10 minutes presentation by Mr. Renewable of SKF India.
Good afternoon all. It's been indeed a pleasure to be a part of this occasion among this elite audience. Thank you all for giving us a chance. I come from SKF India Limited. We call ourselves a knowledge engineering company. We have been into the field of industrial technology over the last 100 years. And we want to serve our customers with our rich experience. We have diversified into multiple platforms, and we try to provide our customers with complete sharp solutions. Our vision is to equip the world with SKF knowledge. So we firmly believe that we have gathered a lot of experience over the past 100 years, more than a century. So we want to provide you solutions based on our experience at the field, working with you as a team. And of course, coming to the renewable energy sector, the theme for today, and sustainability, the drive that the world is facing today amongst various challenges. We also have some things like SKF WindCon, which is an SKF offering specifically for the wind energy area. We have several specialized lubrication systems and special turbine manufacturing solutions. And apart from this also, we have diversified in other applications and solutions as well. We are present in all the sectors, call it metals, call it heavy metals, call it mining and mineral processing, name cement. We are present in every kind of industrial segment that you can name today. And our support is global. We have an extensive distribution network, and we provide you field assistance whenever and wherever you need our help. So of course, bearing is the heart of the machine, so we talk about reliability, and we hear it globally that yes, we are one of the most reliable brands when it comes to bearings. Our capabilities are not confined to only bearings. Our capabilities also migrate to several other areas like lubrication, maintenance products, condition monitoring systems, reliability maintenance equipments, sealing solutions, and of course our specialty product areas like mechatronics products, housings, etc. So our mission has been always to be the most preferred company in terms of our employees, our shareholders, our customers, our distribution network channel partners. And as I told earlier, our solutions are based on 100 years of rich knowledge and expertise. So I talk today about a special portfolio of SKF which is called the Beyond Zero portfolio. The catchline goes that going beyond zero is even better, targeting zero is good. So we want to reduce and have a world free from carbon dioxide emissions. We maintain a special portfolio from our industrial products area, wherein we try to reduce the environmental constraints which we face from the greenhouse effect worldwide. And sustainability is one of the major drives that we have in our own organization. I'm sure you have it with the WBBTCL group as well. So this portfolio works under 3 separate areas: air, water and earth. And we have specific targeted solutions for the several different industrial segments. I also talk briefly about a product. Recently this product has been into the field of deep groove ball bearings used in electric motors. We have showed some of our customers very large energy consumption savings, due to which we were rewarded, and we have received customer feedback that they have saved almost about 70 to 80% of what they consume, what they used to consume higher in a month earlier. We have got performance certification by them. So this is a special Beyond Zero portfolio product which is called the SKF E2 bearing or the deep groove ball bearing, which is also known as E2 or energy efficient deep groove ball bearing. We have several other facilities to facilitate our customers. One of remarkable ones are the remanufacturing services for small and large size bearings, wherein you can have a predictive maintenance kind of operation on your bearings, trying to enhance its life cycle. Before the bearing fails, you can actually send across the bearing to us and we can give you some part of its old life cycle. So today the industry is facing challenges related to asset optimization also. So we have several areas which ensure savings for your asset optimization. You always have this constant war between cost and performance. So we are having a different kind of approach because our core product being bearings, we manage that complete bearing life cycle, and we have complete total cost of ownership based approach towards this bearing life cycle management, wherein we try to bring down your total cost of ownership of the complete shaft system through our several platforms like the 5 platforms, and this saves the major chunk of cost which you actually see in this picture. We normally always relate to our costs as the initial investment that we make on buying a product or a service, but actually we can actually save a lot of cost if you work through the total cost of ownership concept. So these kind of costs which are hidden and are not appearing in your daily basis are labor costs, contractor costs, costs of overhauling, spares, costs for training of your people. So we take interest in these fields, and so we bring down the total cost of ownership for you. So this energy efficient bearing is one of our most important solutions that we have provided now. Apart from that, I'll talk briefly about our application know-how. We have a specialized kind of heat treatment and a very good material. And our heat treatment is also slightly different from our competitors. And we have launched several series of bearings, as you know, from the early inventions from 1907 to today. All the self-aligning solutions that you have, a major problem in the shaft alignment area has been misalignment, and all the self-aligning solutions have been invented by us. And we have made major technological progress in this field. We have even patented a few bearing designs from our end. So briefly, if you talk about a self-aligning bearing system, it would look somewhat like this, wherein at a locating end and non-locating end at a shaft. At the non-locating end, you will have a self-aligning solution. The problem was earlier, the thermal compensation was tackled by a bearing system, usually cylindrical roller bearings, through a sliding motion. But that did not take care of the misalignment of the shaft, which we now have taken care with our new patented design, which is called the car toroidal roller bearing design, which you see here. This is a major product technological breakthrough. So this has obviously some great financial and environmental benefits in itself. I'll also briefly talk about some kind of remote diagnostics, an area in which we have penetrated recently. What happens is when you do PDM practices or take readings to an analyzer, there is a difficulty area that you do not have an expert person to visually inspect the condition of machine and provide feedback. So SKF has come up actually with a remote diagnostic center. You can actually take in data, and from a cloud-based server, you can send in the data to our expert sitting somewhere else, and they can give you their valuable feedback. So this becomes a very important and key solution for our customers, and especially in coal handling plants or power plants, this can be a very important solution. We also have a range of solution factories are open with SKF. We call them a solution factory because the only reason we want to provide you with a solution is that you will have continuous needs which are different and which are according to the plants, the applications that you use. So we now have 2 solution factories for you, one in Pune, the other in Jamshedpur, wherein we take care of your changing needs and ensure that you have the highest reliability in these areas. So you have a solution factory where people can deliver you services and technologies. So these solution factories have a wide range of applications. We can give you field experience, we can do structural analysis, we can give you key-based solutions, we can do remanufacturing, refurbishing. So a wide range of engineering consultancy is also there, condition monitoring expertise is there. We do some kind of special trainings and spindle services. So this is all to provide you solutions for which we take pride. So there is always a solution very near to you. And we have a wide range of certified maintenance partners who are globally spread across, now a lot of them present in India also, to facilitate you with all these services. So we take a lot of pride in these solution factories which we have launched only to serve our dear customers. And these are the basic services areas, a lot of which is not in the scope of this presentation. However, you can always come to us for a lot of your demands. We are of course working with the WBBDCL group for a long time, trying to provide them key solutions in their key segments like coal handling plant or ash handling plants. So that's all about it today. This afternoon, gentlemen, thank you for having a patient hearing. And please come back to SK for any kind of solutions you need for your plant. Thank you.
Thank you so much. Who would be panelists in our technical session 2, which happens to be the final session of this conference. May I request Professor Dr. Debobroto Dash, Professor, Department of Biotechnology, IIT Kharagpur. May I request you, sir, to kindly come up. As also Dr. Prabodh Vajpayee, Professor, Department of Electrical Engineering, IIT Kharagpur. Dr. Debashish Chatterjee, Professor, Jadavpur University. As also Dr. P.K. Sadhu from ISM Dhanbad. And Sri Joy Chakraborty, Divisional Engineer with REDA. We would also request Sri Prateek Singhal, Chief Operating Officer of EcoFrost Technologies Private Limited, to please come up on the dais. Sri Prashanto Sinha, DGM WPDCL. The panelists of Technical Session 2. May I request those of you who haven't yet come to the dais to please come up so that we can complete our panel. Meanwhile, I would be requesting some of our members, the EWF members, to please come up and felicitate the distinguished panelists. Shumon Sarkar, our executive member. Anjan Roy, Secretary of EWF Corporate. Subroto Kumar Shur, Secretary of EWF STPES Zone. J.N. Mondol, Vice President of the EWF Corporate. And Sujoy Ghosh, our Treasurer. Shaun Maji, would you please come up and felicitate our distinguished panelists. May I first request Shumon Sarkar to present a bouquet and welcome Dr. Debobroto Dash, Professor, Department of Biotechnology, IIT Kharagpur. Anjan Roy, our Secretary of the EWF Corporate, would now be felicitating Dr. Prabodh Vajpayee, Professor, Department of Electrical Engineering, IIT Kharagpur. Sri Subroto Kumar Shur, our Secretary, EWF STPES Zone, would be presenting a bouquet and felicitating Dr. P.K. Sadhu of ISM Dhanbad. May I now request Sri Sharanan Mondol to please come up and felicitate Dr. Debashish Chatterjee, Professor, Jadavpur University. And Professor Debashish Chatterjee would now be felicitated by Sri Sharman Mondol. Sri Siddhartha Chaudhary, Secretary, Seminar Organizing Committee, would be felicitating Sri Prashanto Sinha, DJ WPDCL. And we, of course, have with us today Sri Joy Chakraborty, Divisional Engineer of Australia. May I request Sri L.K. Mathal, President of EWF KTPS Zone, to do the felicitation. So we commence technical session 2. May we first invite Dr. Debobruto Das, Professor, Department of Biotechnology, IIT Kharagpur. He would be talking about biomass energy.
Good afternoon, all of you. I am thankful to the organizer to give me an opportunity to share some of our research experiences that we have on this biomass energy recovery system at IIT Kharagpur. The topic that I have chosen today, that is the potentiality of gaseous energy recovery from the organic waste by the highway process in India. Now, if you look at non-renewable and renewable energy sources, I think everybody knows that non-renewable energy sources will be exhausted very soon, and the energy source that will remain with us, that is the renewable energy source. That is nothing but your wind, solar, geothermal, water and biomass. Now this is the trend of fuel usage, and it is very interesting that if you look at our civilization, we started using wood as a source of energy source, and slowly we step into hydrogen and fuel cell. And question comes why we are stepping into hydrogen and fuel cell. The reason is that when hydrogen burns, it produces water. No way it is polluting the environment. And fuel cell, we can generate the electricity with the help of hydrogen. That is also no way polluting the environment. So this is the global energy scenario that we can see the demand and the production from the fossil fuel that will go with side by side up to 2020. After that, your demand, that production from the fossil fuel will get exhausted slowly, but your demand keep on rising due to rapid industrialization and urbanization. So there is a huge gap between the demand and the production. So there is a need of energy from the renewable energy sources. And this is the world scenario that we have. So you can see that hydro, gas and coal occupying the maximum as compared to other energy sources. Now this is the Indian part or scenario that we have, that you can see coal that is occupying, that is 58.5%, whereas your renewable energy source is about 12.99%. Now, this renewable energy source can be, particularly biological energy source can be recovered from the different waste material, and waste material can be classified like solid waste and liquid waste. And solid waste, we have different types. We have municipal waste, we have agricultural waste, we have industrial solid waste, and liquid waste, we have industrial wastewater and the domestic wastewater. We have different classifications. Now, we consider the biomass as a boon to the society, because the reason is that this can not only applicable to the small sector, but it can be used in the larger sector. So 40% of the world primary energy consumption can be already fulfilled from these renewable energy sources. And on average, biomass produces 38% of the primary energy in developing countries. This is a very interesting thing that we have. The different possible two-stage process for the complete conversion of substrate. We have one is the methane generation, and there is the hydrogen production. And this I want to share with you today. Now, if you look at the processes that we have, how the organic material can be converted to the gaseous fuels. So one is the dark fermentation, through which you can produce hydrogen. And after hydrogen production, that whatever metabolites is remaining, or mostly organic acid, that can be converted to hydrogen further by using the photofermentation process. But photofermentation process has several drawbacks because it requires the light energy, and which gives some kind of shading effect. Also, utilization of the light conversion efficiency decreases drastically as the organism grows. But biomethanation process, which is a well-established technology, and that is no need of light energy, can be produced from different ways and large-scale production. And in this connection, I want to tell you that if anybody visited the Western country, particularly Germany or Sweden, you will find a lot of buses are operating by the biogas. So the process that I want to discuss with you, this is the HyMet process. That is the new concept we try to develop. That is hydrogen followed by methane production. So whatever anaerobic digestion processes that has been carried out and is successful in the industrial level as well as in the domestic sector, that is mostly they are concentrating on methane and carbon dioxide production. But if you look at the anaerobic digestion process, usually carried out by the two groups of microflora, one is called acidogens, another is called methanogens, and these acidogens can also use for the hydrogen production, and that is this hydrogen will be added advantage if you combine with the conventional this methane generation process. And what do you call HyMet? Hy means stands for hydrogen, Met stands for methane, hydrogen followed by methane. And if you look at the metabolic, the pathways of hydrogen production in the first step, the complex polymer compound that produces hydrogen in the second step, organic fatty acid is converted to methane and carbon dioxide. Now, question comes, why hydrogen? Because I don't like to spend much time on this, because this is the area we have been doing research last 17 years, and we are quite successful. And I want to share with you that recently we are constructing 10 cubic meter reactor for the hydrogen production, and if we are successful, we are going to invite all the industry in India to go for the commercialization of this process. Now, what is the driving force behind that? To increase the energy density is one time and easiness of transport in other time. So, the reason that you see that energy density in hydrogen is much high as compared to any other fuel available with us. So, this is the highest energy content, clean in use, easy transportation, and free from the impurities and burnt without any soot, smoke and gases. Now this is the hydrogen, why hydrogen is considered to be only the carbon dioxide neutral, because as some of the speakers, I think in the morning session, they pointed out the greenhouse effect, which is the major concern nowadays, particularly in the Western country. Some of the country is already in the sea level, so if the water content increases in the sea level, those countries will be under the water. So hydrogen, besides the energy, hydrogen has several other uses. So this is the different applications we have as per hydrogen is concerned, and hydrogen can be produced by different ways, and we will be concentrating on the microbial conversion of biomass. So benefits of hydrogen economy is strengthen the national energy security, reduce the greenhouse gas emission and air pollution, and improve energy efficiency. Now, why biological hydrogen production? The reason is that essentiality. Essentiality means the constant of the conventional production processes that can be overcome. The constant of the conventional processes is high temperature and high pressure. Our biological system is usually operated at ambient temperature and atmospheric pressure. And versatility is that offer the potential production from the variety of renewable resources, particularly refuse and waste that poses some kind of environmental pollution problem. And third is the naturality, that is the near zero pollution and cost-effective process due to simple techniques. Now, why the Swiss sludge and other waste we consider for this production? The reason is that abundant renewable biomass, high nutrient and microbial content, management and disposal program and environmental hazard. The diverse biological hydrogen production processes is given here. You see that we have mainly the dark fermentation process and photofermentation process. Dark fermentation process is controlled by mesophile and thermophiles. And the metabolite that is produced, organic acid, can be passed through the photofermentation process to produce hydrogen. And then, if you look at the biohydrogen research in the world, initially started with algae. The reason is that scientists started thinking if we can degrade the water into hydrogen, nothing like that, because 3/4 of the earth is content water, so we have sufficient amount of energy source. But when we try to convert water into hydrogen, it produces oxygen, molecular oxygen, which gives some kind of inhibitory effect on the enzymes those are responsible for the hydrogen production. So this research is further continued, how to develop a nutrient which can have the resistant property for this molecular oxygen. But we can use this also through this microbial carbon capture cell for the production of hydrogen. This is the various approaches through which we can produce hydrogen. This has been shown here, and this is the pictorial presentation of the hydrogen production process what we have. So only I want to highlight that industry which is produces carbon dioxide that can be sequestered in the form of algal biomass. This algal biomass can be used for the production of hydrogen, and besides that, this algal biomass can be used as a substrate also for the production of hydrogen. So these are the metabolic pathway, and the advantage, as I told you, that it can operate at ambient temperature. I don't like to repeat it again. And this is the roadmap, because I want to tell you that Government of India has given IIT Kharagpur to lead a group for writing the roadmap on hydrogen, particularly on biohydrogen production processes. So we are leading a group with 5 other institutes in India, and we try to find out the suitability of this biohydrogen production processes. We started this work in the year 1999, and first publication we have 2000. You can see our roadmap. We have different areas we work on, and these are the several publications we have. And all these information are available in our website, www.bioh2iitkgp.in. So let me tell you something on biohydrogen, what the process we want to share with you. The organism that we isolated initially, that which has great potentiality for the production of hydrogen, is the Klebsiella pneumonia. Previously it was known as Enterobacter cloacae. Now it is a gram-negative bacteria, rod-shaped, facultative anaerobe. It can easily grow, mixed acid fermentation process is followed. And first review paper that we published in the International Journal of Hydrogen Energy, I am glad to report here, the citation number of that is 1517, which is the highest among all the hydrogen, that biohydrogen paper that has been published so far. And the organisms that we have used, we have Citrobacter 20, we have Bacillus, we have Rhodobacter, we have thermophilic mixed consortia that we use in this study. Now the organism has the speciality of using different carbon sources, which indicate its potentiality of using different waste material containing different organic matter. And this is, you see that this organism has the characteristics of growing both aerobic and anaerobic condition. And if you look at aerobic anaerobic condition, if you see the pH profile, up to 10 hours, it will go, the profile will be same. After 10 hours under aerobic condition, its pH increases. Anaerobic condition, its pH decreases. and your hydrogen production mostly takes place under anaerobic conditions. So this is 6.5 pH was found most suitable. We also studied the effect of partial pressure on this hydrogen production. If you look at the Lee-Catlier principles, which is the equilibrium constant equal to concentration of product divided by concentration of substrate. Since our product is a gas, you can suck the gas, with the negative pressure you can take the gas out. As you take the gas out, your more substrate will be converted into the product, your productivity of the system increases. So we use different immobilized system and we find it suitable for the hydrogen production because the cell that adhere on the surface of the solid matrix is more by using special type of solid matrix. This is the reactor, different type of reactor. Renewable reactor we find more suitable for the backbed reactor. And this is the solid matrix where the bacteria that immobilize on the surface of the solid matrix. You can see how the bacteria that oozes out from the surface of the solid matrix and it produces hydrogen. And this is the different reactor configuration that we use, tubular, tapered and rhomboidal type of reactors. And this is how they differ from each other. I don't like to go in details. And so let us share some of our recent experiences that we have on this. We try to use different waste material. And before we try to use, first we characterize those materials. Those are cheese whey, distillery effluent, cane molasses, starchy wastewater, brewery sludge, and dairy sludge. And then we also use, because you know that microbial system is such a system, is required some nutrient for their growth and multiplication. So we use, in the normal growth media, we use yeast extract, malt extract, those are very costly. So we try to substitute by using like de-oil groundnut cake, de-oil coconut, then mustard, sesame and rice bran. And we try to find out how it is suitable for this production and we are quite successful. If you look at this, we compare with different waste material, how your gas production occurs, and you find that using the cane molasses, the continuous system, our gas production is 18.5 moles of hydrogen per kg CO2 reduced. Now, this is the substitution of this groundnut de-oil cake. You can see the hydrogen production is quite high as compared to that of the malt and yeast extract. So we are quite successful on that. Here, this is the 20-liter reactor that we have operated, and if you go to our website, we have given you the live demonstration of our plant, because you know that 20-liter reactor, how it is operated, and I am glad to report you that produces 67.7 liters per hour of gas. And this is the 800-liter reactor we operated at IIT Kharagpur. This is also quite successful. Now we are going for 10,000-liter reactor. Now the problem, because previous system we worked with mesophile, which work at 37 degrees centigrade, but only the problem is that you have to sterilize the media, which is very energy intensive. So what we are thinking, is it possible to replace by thermophiles, which has high reaction rate, solubility of hydrogen decreases, less byproduct formation, less risk for contamination, feasibility to use the hot industrial effluent, can use variety of substrate and low viscosity, so better mixing. So we are quite successful of using this, and we got 12.2 moles of hydrogen per mole of glucose by using this, by using mixed culture. And presently my research group is working with mixed acidogenic culture, and we are also quite successful. We published the paper in several journals. And this is very interesting thing that we observed that NADH plays very important role in this hydrogen production process. And we find that when NADH concentration is very less, hydrogen production is maximum. That means NADH is mostly consumed for hydrogen production. When it increases, that means hydrogen production decreases. This has been we recently observed. We operated 20-liter reactors, and we find out that by distillery effluent we got 2.2 liters per liter of the reactor volume, and cane molasses we got 4.8 liters per liter of the reactor volume. In the methanation process, we work with different type of organic waste. We have cow dung, water hyacinth, and we came up with the mixed biomass is found more suitable for hydrogen production. The reason is that it gives the proper nutrient to the microorganism for growth and metabolism, which increases the that methane production to a great extent. And this also we work with the spent media that obtained from the dark fermentation process, and this is the energy analysis we try to do with if we combine this hydrogen production with the methane production, we find the energy recovery can be increased 58.8%, because I'm definitely it can be increased further. It can be increased as high as 65 to 70%. And whereas normal this hydrogen, the methane production processes where our energy recovery is around 40%. And this is the work I did in IIT Delhi, and I find that this by using distillery effluent also you can successfully use for the production of methane without any coal, which is operated by different industry. In conclusion, I want to say that hydrogen production through the biological route will be attracted by considering the organic waste as a substrate. Waste are unsuitable as substrate mainly due to the complex nature and lack of essential micronutrients. The agricultural processing industrial residue like de-oil cake appears to be the most promising as the nutritional supplement in the hydrogen production media to increase the overall hydrogen yield and decrease the production cost. Two-stage process such as HiMet is very much promising for higher energy recovery from the organic waste. This is the book we published last year, Hydrogen Production, Fundamentals and Technology Advances. This has been published by CRC Press, New York. And this is the textbook. If anybody interested to know something about the biohydrogen production processes, they will read it. They can know everything A to Z on this process. And this is, I'm thankful to my different financing organizations. We have Department of Biotechnology, MNRE, DRDO, then DST, NSF, and DAC. We have several collaborating institutes. This is my research group, present research group, and these are the different students contributed in our research activity. This is our department, biotechnology, and this is the IIT Kharagpur. IIT Kharagpur doesn't need any introduction because this is the first IIT in India. Thank you.
Thank you so much.